You know, for hundreds of years, the microscope has been our main window into this incredible, invisible world. But let's be honest, that window has always been a little fuzzy, a little tricky to look through. What if, though? What if we could get a perfectly sharp, totally clear, even 3D view of that hidden world? Well, today we're going to dive into the amazing revolution that is digital microscopy.
All right, so to really get why this new tech is such a game changer, we have to go back to the basics. We have to talk about the huge problem that every traditional microscope has always had, a problem I'm willing to bet you've run into yourself. Yeah, does this ring a bell? You're in science class, you're hunched over the eyepiece, you're fiddling with that little black knob, and you get the very, very top of your sample perfectly sharp, but then everything else is just a blur. So you focus a little lower, and now the bottom is sharp, but the top is completely out of focus. It's this constant, frustrating trade-off. So, what's the deal? Why is it so incredibly difficult to just get the entire object in focus at the same time? Why can't we just see the whole thing, top to bottom, crystal clear?
Well, it all boils down to this one little concept in optics called depth of field. Basically, it's the zone where things look sharp. And with a normal microscope, especially when you're zoomed way in, that zone is ridiculously paper thin. We're talking microns. Anything, and I mean anything, outside that tiny little slice is going to be out of focus. But what if you could just completely shatter that limitation? This, my friends, is where the digital microscope revolution kicks off. And we need to be super clear about this. This is not just a regular microscope with a camera stuck on it. No way. It's a whole new beast, a complete imaging system where the optics, the software, and even robotics are all working together.
So you can just toss out that old image in your head of the static microscope that hasn't really changed in 100 years. This new system is modular. It's adaptable, and it's built from the ground up for a completely new way of seeing things. And the power, the real heart of this system, starts with its unbelievable optics. Instead of having just one or two lenses you can swap between, this thing has a literal arsenal of specialized lenses. Each one is a little masterpiece, engineered for a very specific job, whether it's looking from far away or zooming into insane levels of magnification. And you won't believe how fast this technology has been moving. I mean, it all started back in the 90s, and the first big step was just getting rid of the eyepieces and putting a monitor on instead. But then boom, 3D observation came along, then better imaging, and then, in the fourth generation, the real magic happened, real-time depth composition. And now, we're living in the age of 4K Ultra HD accuracy. It's been a wild ride.
Okay, so let's get to the really cool part. How in the world does this new system actually fix those ancient problems of focus and having a super tiny field of view that have always plagued microscopes?
The first bit of wizardry is something called depth composition. Here's how it works. As you turn the focus knob, the microscope is actually recording a super high-speed video. The software then goes through every single frame of that video, finds only the parts that are in perfect focus, throws away all the blurry bits, and then stitches all those perfect little pieces together into one final, flawless image. And the result, just look at this, it's night and day. On the left, you've got the old way, a blurry, frustrating, incomplete picture. But on the right, with that digital composition, every single piece of that object, from the very top to the very bottom, is just perfectly, breathtakingly clear. You see everything.
To give you an idea of how big a deal this is, this method gives you an effective depth of field 20 times greater than a conventional microscope. At 20x zoom, you can get a whopping 34 millimeters of height totally in focus. That's the difference between seeing a single grain of sand and seeing the entire beach.
So, okay, problem number one, focus, is solved. Check. But what about that other big headache? You know, when you zoom way in to see detail, your view shrinks down to a tiny little peephole? Well, the digital system has another brilliant software trick for that: automated image stitching. The easiest way to think about it is like the panorama mode on your phone. The microscope's motorized stage just automatically moves the sample around, snapping hundreds of pictures in a grid, and then the software seamlessly stitches them all together. What you get is this one massive, incredibly detailed map of your entire sample. All right, so now we've got a perfectly sharp image, and we can see a huge area. That's already mind-blowing, right? But the next step, this is where things get really wild. We're about to break out of the flat 2D world completely and jump into the third dimension. It actually starts with the hardware itself. This amazing free angle system lets the camera and the lens tilt and rotate all over the place. So you're no longer just stuck looking straight down. You can see your object from the side, from an angle, from pretty much any perspective you can imagine. This alone gets rid of all the blind spots. And here's the really genius part. Remember that stack of images it took for the depth composition? Well, the system throw that data away. Since it knows exactly where the lens was for each and every focused slice, it can use that information to calculate the precise height data for every single pixel in the image.
And bam! This is what you get. With literally one click, the software builds a fully rendered color 3D model of your sample's surface. You can spin it around, you can zoom in, you can even slice it open to take measurements of its profile. It's incredible.
So why does all this matter? I mean, this is the crucial point, right? It's not just about making pretty pictures or cool-looking 3D models. Having these perfect images unlocks a whole new universe of powerful automated analysis. All of a sudden, the microscope stops being just a viewing tool and becomes a ridiculously precise measurement instrument. It can automatically count and measure particles, analyze the grain structure in metal, spot contamination. It can do all these complex jobs that would have been either impossibly tedious or just, well, impossible before.
And the speed. My goodness, the speed is just off the charts.
An analysis that might have taken a person hours of careful manual work. The system can now do it automatically, and more accurately, by the way, in just a few seconds. You know, the brochure for this thing actually sums it up perfectly. It calls it a completely new, customizable microscope system to meet a wide variety of needs. And that's exactly what it is. It's a fundamental rethinking of what a microscope can even.
And that really brings us to the big final question, doesn't it? For so long, our understanding of the microscopic world was defined by the limits of our tools. Now that software and robotics have just completely shattered those old limits, it really makes you wonder, now that we can finally see the unseen this clearly, what are we going to discover next?
Let me end with a short story. 10 years ago, a quality engineer judged defect with the naked eye. Sometimes it looked like a pigment issue, sometimes a processing problem, but there was no proof. Today, that some engineer placed the sample under digital microscope. A black speck appears. Carbon agglometer 40 microns. Decision because clear loss is prevented. Technology didn't change the material, it changed the way we see it. And this is just the beginning. If you working in plastic color matching or quality control, you don't want to miss what